Units of measurement. Units essentially tell the standard quantity to which we are comparing a measured property, which essentially means it gives a definition to your numbers. For instance, if I say I am 40, what does that mean? Am I 40 pounds? Am I 40 kilos? Am I 40 years old? So whatever you see right next to it, this is a unit that gives definition to the number 40. So these are units. There are several measurements that are made, for example, length, weight, height. So all of these different measurements have different units. These are the standard units that are used. For instance, for length, the standard unit that is used is meter. Mass, the standard unit is kilograms. When we say standard unit, those are the units that are usually used by scientists all around the world, because there are so many different units that can be used just to express weight, right? To express mass of a substance, we can use grams, pounds, kilograms, milligrams, all those units are used. But there's one unit that has been set and defined as a standard unit, which is applied all through the scientific community all around the world, and those are the standard units. For time, it is seconds. For temperature, it is Kelvin. Kelvin, if you're not familiar with, Kelvin is basically an absolute unit for temperature. Absolute means it does not have any negative numbers. For instance, when we talk about temperature, we say temperature can go in negative Fahrenheit or negative degree Celsius. It can be -5, -10 Fahrenheit or degree Celsius, whereas Kelvin can never be negative. That's why it is called absolute unit. All the numbers in Kelvin are always positive. When we measure amount of substance in chemistry, the unit that is used is mole, okay, which is abbreviated as also mole, except the E at the end. What is this? We'll talk about that later on in later chapters, but basically this is one of the units that is commonly used for amount of substance in chemistry. Electric current, the unit is amperes. The intensity of light is measured in candela. This unit system that is used is called the SI system, which stands for System International. That basically means it's an international system that is applied or utilized throughout the world. These are some other standard units that are used. This is not SI, this is the metric system. Metric system is the one that is commonly used around the world, but not in the scientific world. For example, the only major difference here is mass. Usually in the metric system, we use the grams as the unit for mass. Everything else apart from this is same. Another unit you might commonly see being used is for volume. Usually we measure volume in liters. Along with the SI unit, there are some prefixes that are used. What are prefixes? Prefixes are just some terms that are used in front of a SI unit. For example, if I'm measuring length, the SI unit for length is meters. But if I am measuring distance between cities, usually it is very difficult to measure that distance in meters because that distance is pretty long. So instead of meters, the commonly used unit is kilometers. And what is this small k that we put in front of meters? That is called as the prefix. For example, when we are measuring mass of an object, the unit, SI unit that we usually use is grams. And what is a prefix that you might have heard in that is put in front of grams, that might be kilograms, or you might have heard milligrams. So these are basically just the different prefixes that are used in front of units. So prefixes are always a power of 10. Okay, for example, this right here, these are different prefixes that are used: centi, deci, kilo, mega, giga, tera. These are the abbreviations that are commonly used for these. Okay, the important thing to remember here is this meaning. Okay, remember this meaning is always applied to the base unit, and 1 is always applied to the prefix. For example, if I'm interested in knowing what is the unit or the relationship between kilograms and grams, my base unit is grams. Base unit is the normal without any prefix unit that is used to measure that quantity. So if I'm measuring mass, my base unit will be grams. I can put any prefix out of all of these. Only important thing is 1 always comes in front of the prefix unit. So for example, 1 kilogram is equal to, tells you right here, kilo is 10 raised to power 3. So it is 10 raised to power 3 grams. These prefixes can be applied in front of any unit. For example, if I'm doing mass, I'm using grams. If I want to do distance, I would do meters. In that case, 1 kilometer, again, 1 always comes in front of the prefix unit, is equal to 10 raised to power 3 meters. And that is my unit. The relationship between two different units. You could apply this prefix in front of whatever quantity we want. For example, seconds. If I want my base unit, let's say is time, I'm measuring time, my base unit is seconds. I can say 1 kilosecond is 10 raised to power 3 seconds. The same relationship, this prefix is always going to be 10 raised to power 3 of its base unit. You can keep on changing the base unit to grams, to liters, to meters, whatever is the measurement, but the relationship will always be 10 raised to power 3. 10 raised to power anything, as long as it's a positive, like these, 10 raised to power positive 3, 10 raised to power positive 6, that means it is 10 multiplied by itself that many times. So 10 raised to power 3 is 10 times 10 times 10 3 times, which is 1000. So you can also say 1 kilosecond is 1000 second. 1000 and 10 raised to power 3 are basically the same thing mathematically. The other units that are usually smaller in prefixes, deci, 10 raised to power minus 1, centi, 10 raised to power minus 2, milli, small m, micro, even though it starts with an M, the prefix abbreviation that is used is this weird looking U. This is called the micro. Nano is N, pico is P, femto is F, atto is A, and all these are their relationships with the base unit. So for example, if we want to know a relationship between milli with its base unit, the relationship is right here. 1 milli of anything is 10 raised to power minus 3 of that. So for example, if I'm measuring mass, my base unit will be grams. So 1 milligram is equal to 10 raised to power minus 3 grams. 10 raised to power negative anything means it's 1 over 10 that many times. So if it is 10 raised to power negative 3, 10 raised to power negative 3 is same as 1 divided by 10 3 times. Okay, so that would give you this, which is also same as 0.001. But usually these decimals are difficult to remember, so we usually remember it like these exponents, 10 raised to power negative 3. Example, I could apply this in measurement. For example, let's say I'm interested in liters right here. My base unit is liter, 1 nanoliter. If I'm interested in a relationship between nanoliters and liters, remember 1 always goes in front of this. So 1 nanoliter is equal to these many liters. 1 picometer is equal to these many meters. 1 femtosecond is equal to these many seconds. That's how it goes. You can apply these prefixes in front of any unit. The value 10 raised to power that value never changes. These are some more derived units for the SI system. For example, if we are measuring volume, volume is usually length times width times height. The unit for length by SI system is meter, times width is also meters, height is also meters. So eventually meter times meter times meter gives you meter cube or cubic meters, and that is basically a derived unit. It is derived by using the normal base units. So these are all derived units. For example, speed is what? Speed of a car is basically distance traveled by it in a given amount of time. The unit for distance, let's say, is meters, its length. Time is, let's say, second. So your speed is meter per second. It's not a new unit, it is a derived unit which is derived by using the previously known unit. So that's why these are called as derived units. Example, acceleration, meter per second square. Density is kilogram per cubic meter. So these are not new units that we have come up with. These are just units that are derived. Another quantity that you might commonly see is volume, which I just explained to you. Volume is usually length times width times height. It is how much space is occupied by a substance. So most of the times, as long as all these three units are same, meter, 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 it would be cubic meters. If all these three are centimeter, 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 then your final unit will be cubic centimeter. So volume unit is a derived unit that can depend on what is your length being measured in. Another commonly used unit for volume is liters. That is commonly used when we are working with liquids. So there's also a relationship that relates liters with other units. For example, this 1 milliliter is 1 cubic centimeters, or 1 milliliters is 10 raised to power minus 3 liters, which is already known, what we saw earlier. Milli, small m in front of anything, is 10 raised to power minus 3 of that base unit. So 1 is this conversion factor that you should remember from the previous table. Another one is 1 milliliter is 1 cubic centimeter. So they are related to each other. Okay, and these are their relationships if you ever need to convert between two given units. These are some SI unit and English unit conversions. English unit basically means some units that are commonly used that are not standard units. For example, when we are measuring distance, there's a commonly used unit called as inches, or we also measure length in feet. We also measure it in yards. We also measure length in miles. But all of these are basically units of length. They measure length, height, distance, right? So we need a conversion factor that relates all of these, and that would be this. A relationship that relates meter with inches, centimeters with inches, miles with kilometers, kilometers with yard, kilometers with feet. So these are just a relationship between any two units, and we usually call these relationships as conversion factor because it helps you convert between two units. Example, if we talk about mass, some commonly used unit is gram, but there's kg. These are related to each other by prefix, we know that, but then there are some units that are like pound, ounces, okay, or metric ton. How are these related? There are no prefixes, so they are related by these conversion factors. Okay, example, another example is volume. Volume can be measured in liters, milliliters, which is good because we can relate them using prefixes. But there's also some other units like quarts, fluid ounces, gallon, pint. So these are the conversion factors between them. You do not have to memorize these factors. If a question is given to you, it will always provide you with these numbers or with these relationships. You just have to know how to use them. Again, you don't have to memorize those. They will be given to you, or if you are attempting a question, you can use these notes to find your conversion factor. Now, why are we learning about all these units? One, usually you will see these units very commonly in chemistry, because a lot of times we are dealing with very small numbers or pretty large numbers. Okay, usually the small numbers. So that's when we need these units, so we can use the appropriate unit, right? So for example, again, if I'm measuring distance between two cities, I would rather measure it in kilometers than thousands and thousands of meters, right? Another approach is, another important factor is using dimensional analysis. Dimensional analysis is basically just an approach to solve your question using units. If you do not know the formula, you can just work with the units. For example, just how we multiply numbers. For instance, if I say 2 times 2 is 2 to the power 2, which is 4, right? Similarly, if I say meter times meter, you can multiply the units as well, and it becomes meter squared. If you say 2 times 2 times 2, that is 2 cube, right? You can also similarly say centimeter times centimeter times centimeter, which is cubic centimeters. You can say 4 divided by 2, or let's say something else. Let's say 8 divided by 2 is 4. Similarly, if I say meter square divided by meter, this is meter square means, remember square means it's the same thing 2 times, which means I can cancel this. So meter square divided by meter is same as meters. Just how you can cancel these numbers, you can also cancel units. Just how you multiply numbers, you can also multiply units. Just how you add numbers, you can also multiply numbers. Add numbers. What does that mean? For example, if I say 2 centimeters, I'm measuring the length of this object, let's say, okay, and I bring a ruler. The ruler is only a little, it's a small ruler, so it can only measure few things at a time. So I measure this, and it came out to be 2 centimeters. Then I measured this distance, it came out to be 4 centimeters. So what is the total length of this object? It would be 2 centimeters plus 4 centimeters, which is 6 centimeters, right? When you add, you do not like say centimeter square, because that's when you multiply it. So when you add units, it's the same unit. When you subtract units, so if I say 4 centimeters minus 2 centimeters, that would leave you with 2 centimeters. When you're adding and subtracting, it's the same unit. And you cannot add or subtract different units. It has to be the same unit. Similarly, you can multiply or divide the same units as well. And this is dimension analysis. And we will use this approach to solve a lot of our questions. Okay, for example, this is explaining you how the questions are. And I'll show you the approach using example. First thing, for example, if I'm working with a unit of inch and centimeters, my conversion factor is 1 inch is 2.54 centimeters. Okay, this is a conversion factor to go between units. I can use this conversion factor as a fraction. How? One of these quantities will go in numerator, one of these quantities will go in denominator as a fraction. So for instance, if I put 1 inch in denominator, it becomes 2.54 centimeters divided by 1 inch. Or I can do reverse, which would be 1 inch divided by 2.54 centimeters. So these are my conversion factors. How do we solve a question? You pick your starting number. Okay, you start with your starting number, whatever unit is given to you. You take your starting unit, the start unit, and you will multiply it with this factor. One of these factors. Either this or this. How do I decide it? Which factor to use? Whatever is your starting unit, the same unit should be written right across, right here. Start unit. And other unit should be written on top. Okay, which is going to be your desired unit. And because this unit is being divided by this, they will cancel out, and your final answer will be in your desired unit. Okay, what does that mean? For now, just remember, you start with your starting unit, you multiply it with a conversion factor, and that factor is always written as a ratio. Who goes in the denominator? It's the same unit. These units should always be crisscross from each other. If this is in the numerator, the same unit in the fraction should go in denominator. They should always crisscross so that they can cancel each other out. Okay, let's see what does that even mean. For instance, if this is a question, how many meters are in 5.200 micrometers? Okay, question. What I like to do is I like to create a solution map. For instance, I will write down what's given to me in question. What's given to us is micrometers. So micrometers is given. I write whatever is given on the left side of my paper, and the question is asking to convert it into meters. So I'll write meters on the right side. Now what we need between these two units is a conversion factor that relates them both. Either you could find a conversion factor that has both of these units. Okay, if not, we will try another approach that I'll show you later on. Okay, for example, is there a direct relationship between micrometers and meters? Okay, if you remember from the prefixes chart, micro, this common thing between them is meter and meter, which means that's a common factor, and the prefix that is here is micro. So we know from our conversion factor prefix table, 1 micrometer, 1 always comes in front of the prefix, is 10 raised to power minus 6 meters. So if this is my relationship that relates these two units, and once you have this relationship figured out in this manner, that tells you that this is the approach you will be using. Always write down what's given to you. The starting unit is this unit, the number that's given to you. This is the desired unit that I want to figure out, and this is the relationship that relates these two units directly. So now we will use dimensional analysis, which is you start with your starting unit. So I will write 5.200 micrometers, multiply it with a fraction. This fraction comes from the conversion factor that we wrote right here. Now I have to decide one of these numbers and one of these units needs to go in the denominator, one goes on in the numerator. How do I decide? It depends on my starting unit. My starting unit is micrometers, so what goes right below it across is micrometers. So where is micrometers? Right here. So I'll just simply pick and write the same thing right here, 1 micrometer, and whatever's left goes on the other side, which is the numerator now. So now based on this, if I just work with units, forget the numbers, if I just try and cancel numbers, micrometers and micrometers will cancel out, which only leaves you with the unit meters. And that's the same unit that I wanted right here, which means if I plug these numbers in my calculator correctly, I have my answer. So how do you want to plug these numbers? It is 5.200 times 10 raised to power minus 6 divided by 1. If you don't put 1, that should also do it, right? Anything multiplied or divided by 1 is same number. So just plug this into your calculator and it would actually give you the same thing, 5.200 times 10 raised to power minus 6 meters. So that is your answer. Always start with the starting unit, cancel it out, and write the other unit now. And when you're plugging these numbers in your calculator, please make sure you're doing that correctly. Okay, in your calculator you should have an option with 10 raised to power something. It might be x raised to power y. So first type 10, then put xy, and then it will give you the option of what goes here. So include the positive number, negative number, okay, accordingly. But please make sure you know how to solve and plug these numbers into your calculator. Let's try one more question. Convert 7.8 kilometers to miles, and this is the conversion factor that's given to you. What's given to you is kilometers, so that's, I'll put it on the left side of my page. What I want is miles, so that goes on the right side. And the conversion factor that relates the two is given to you. So 1 kilometer is 0.6214 miles. You just need anything. It does not necessarily mean this has to be 1 or the other one has to be 1. Whatever conversion factor you remember. Now we start with the number that's given, 7.8 kilometers. This right here that we drew is called the solution map. Okay, this is, you write what is given, you write what you need, and you make a relationship between the two that will help you solve this question. So each time you will see I will be using this approach throughout the course. So please make sure you understand this. Starting unit, ending unit, and the relationship between the two. If there's a direct relationship like this, great. If not, you need to find like midway steps in between. Okay, first let's solve this. 7.8 kilometers is my starting point. Multiply it with a factor that comes from this fraction. One of these units and the numbers needs to go in denominator, one goes in numerator. How do I decide? It depends on my starting unit. My starting unit is kilometers, so kilometer needs to be written right across from it, which will give you 1 kilometer right here. I'm just taking the number, putting in front of the unit, and 0.6214 miles goes on the numerator. Now we work with units. Forget the numbers for now. Kilometer gets cancelled, and your final answer is in miles, and that's exactly what I wanted. Now only thing you have to do is plug it in calculator. 7.8 times 0.6214. Okay, and that is your answer. Now one trap where students usually get stuck here is when they are doing these conversion factors, they just assume one will always be in the bottom, like right here. It's not necessary. That depends on what is your starting unit. Okay, so please don't make assumptions here. You just follow the rule, which is write your starting unit, and whatever's your starting unit goes right across right here. That's it. Okay, if we solve for this in your calculator, it would give you answer as 4.84692. Now we go by sig figs. This is multiplication. So this is 2 significant figures, and this is 1, 2, 3, 4 significant figures. In multiplication, the rule is least number of sig figs. So this is 2 sig figs. This is 4 sig figs. So my final answer should be 2 sig figs, which means the answer should end right here. The following digit is 4, so I will round the number and keep it the same, which is 4.8 miles, and we are done. Okay, let's try one more. Convert 30 grams to ounces. The conversion factor is given. Again, your starting unit is grams. I want to convert it into ounces. The conversion factor is given to you right here. We start with 30.0 grams multiplied by this conversion factor. Now again, should I divide by 1, should I multiply by 1, or should I divide by 28, should I multiply by 28? You don't have to think about it. The units will tell you. Starting is gram, so what goes in the bottom is gram. How many grams? 28.32, which means 1 ounce goes on top. Gram cancels, your final answer is in ounce. And you see how this when we multiply with this, gram and gram gets cancelled. Okay, now for the answer, this is 1, 2, 3 sig figs. This is 1, 2, 3, 4 sig figs. So your final answer should have 3 sig figs. So it gives you, the calculator will spit out this number when you plug it in, and you can see how in this case 1 ounce is on top and not at the bottom. So your question will tell you where who goes in the numerator, who goes in denominator. Okay, so don't make assumptions. Now this was 3 sig figs, 1, 2, 3. My number should end right here. Following digit is 8, which means I will round the number up. It will become 1.06 ounces. Let's try another question. How many cups of cream is 0.75 liters? So what's given to me is liters, 0.75 liters. So that goes on left. The question is asking me convert it into cups. And the conversion factor that's given to me is liters is equal to quarts. Quarts is equal to cups. What do I know? I need a relationship between liters and cups, but that's not given to me. You need a direct relationship. If that is not given to you, you always need to find a connecting link between these two units. Okay, for example, what's given to me? Liters to quarts, quarts to cups. Do we see a unit which is common to both these factors? Quarts. So which means if I can convert liters to quarts first using this, and then I can know my quarts and I can convert it into cups using the second conversion factor. So the common unit here is your midpoint between the two. Midpoint, or your middle step between the two sometimes. And the relationship here is 1 quart, 1.05, sorry, 1 liter, 1.057 quart, 1 quart, 4 cups. Okay, so you just start with your liters, 0.75 liters. You multiply it with a conversion factor that comes from here. One of these numbers needs to go in denominator, one needs to go on top. Liters will go at the bottom because my starting unit is liters. 1 liter, 1.057 quarts. Now if you work with your units, don't have to solve the question yet. Liter and liter will cancel each other. The unit that I'm left with is quarts, which means I've reached this point. I have my answer in quarts. Now the next step is I need to convert quarts into cups. Now that's your choice. You want to solve this first and then move on to next step, or I just like to extend it. I multiply it with the second factor now. Now my starting unit is quarts, so who goes in the bottom? Quarts. 1 quart and 4 cups. Again, I'll work with units. Quart and quart cancels out. My only unit that's left is cups. So, and that's exactly what I needed. So if I solve my numbers now, I should get how many cups, which would be 0.75 times 1.057 times 4. Again, these numbers are usually exact numbers, whereas 0.75 is a significant number. So this is 2 sig figs, measured quantity, which means my final answer should have 2 sig figs. 2 sig figs right here. If you plug it in, the calculator gives you 3.171. I want 2 sig figs, so my number should end at 1, 1, 2. 7 is the following digit is greater than 5, so it will increase. I'll add 1 here, which means my final answer is 3.2 cups. So please make sure you are following the rules of significant figures when solving any question in chemistry. Let's try one more question. Calculate the number of seconds in 5.175 hours. Hours are given to you, and the question is asking me to convert it into seconds. Do we know a direct conversion factor between hours and seconds? I do not. What I know is that 1 hour is 60 minutes, and I know that 1 minute is 60 seconds. So these are my units that I know. And what is the common unit that I see in between? Minutes, which means that's my common factor. So I will make a extra stop in the middle, which will be minutes. And my conversion factor here will be 1 hour, 60 minutes, and 1 minute, 60 seconds. So what you're trying to do is you're trying to find a relationship between these two units, minute and second, hour and minute, hour and minute. And either of these units can be 1, and either of these units can be a different number than 1. Okay, it's not necessary that because hour is on the left, hour should be 1. That's not necessary. Okay, that just depends on what is your unit, because we decide who do we divide by, who goes in numerator, who goes in denominator, depending on our starting unit. So my starting unit now is hour, so I'll start with that, 5.175 hours. Multiply it with a conversion factor that comes from this. Who goes in the middle, bottom? Hour, because this is hour. 1 hour, 60 minutes. Hour, hour cancels. My left unit is minute, which means I have reached this part of my question. Now I just need to convert minutes to seconds using this conversion factor. So I'll multiply with another factor. This time my starting unit is minute, so my bottom denominator unit should be minute, which is what? 1 minute, 60 seconds. Minute, minute cancelled. Your final unit is seconds. So it would be 5.175 times 60 times 60 divided by 1. 1 does not matter. So that would give you your final answer. Now, sig figs. This is 1, 2, 3, 4. 4 significant figures. This right here, infinite, ambiguous. This right here, ambiguous. Why? Because these are counted numbers. These are exact numbers. They are not measured quantities. Okay, so that gives you 18630 seconds. We said 4, 1, 2, 3, 4 sig figs. So this also has 1, 2, 3, 4 sig figs. This 0 is not significant. Even though you have to write the 0, you can't ignore it, but it's not a significant digit. So you can keep this 0 right here. And you will have to keep this 0 right here. Why is it non-significant? Zeros on the right are not significant until unless there's a decimal in the number. There is no decimal in this number. Let's try one more question. A cheetah can reach a top speed of 75 miles per hour. Convert 75 miles per hour to feet per second. The conversion factor is given to you between feet and miles. Okay, so this time it's not just one unit. It's not convert miles to feet. It is a combined unit. It's a derived unit. Miles per hour. Per means it's divided by that. So what's given to me is miles per hour. And the question is asking, convert this into feet per second. Only conversion factor that's given to me is between feet and miles. So I can convert miles to feet directly, which is great. But I also have hour here. So if I just use this conversion factor, miles to feet, I will get feet divided by hours, right? You can only convert one unit at a time, and the conversion factor is 1 mile, 5280 feet. Now I need to go from feet, and feet are same here, but I need to convert hours to seconds. How do I do that? Remember, we can convert hours to minutes first. So feet will stay as it is. I will convert hours to minutes. So feet divided by minute. 1 hour, 60 minute. 1 minute, 60 seconds. Because here feet is same, minute is going to seconds. So we start with the number that's given, 75 miles per hour times factor that comes from here. My starting unit, because this is a slightly confusing when you write mph like this, miles per hour, we can, to make our life easier, we will write it as miles per hour, meaning miles divided by hour. So first conversion is I need to convert miles to feet. Who goes in the bottom? Miles, because my starting is miles. So 1 mile, 5280 feet. Mile cancelled. I'm left with feet divided by hour, which is right here. That's what I wanted. Now we will multiply it with another factor that comes from this conversion factor. Okay, my starting unit is feet. So who goes in the bottom? Oh, sorry, not feet. Feet is done, right? We are done with the feet. What we need to do is we have to convert hour to minutes. That's my conversion this time. Sorry, we are converting hours to minute. So my starting unit now is hours, and it's listed at the bottom, and it should always be right across, which means hour will be here and minute will be here. 1 hour, 60 minute. Now remember, the whole purpose of writing them across from each other is so you can cancel them. So if I cancel hour with this hour, I can do that. Now again, my next conversion is minute to seconds. Feet stays as it is, so I'm not touching this. My minutes are right here, so I need to convert minutes to seconds. So what is my conversion? 1 minute 60 seconds. My minute is here, so my second minute should go right across, opposite direction, and seconds will go in the bottom. 1 minute 60 seconds. Minute and minute cancelled. What is the unit that we are left with? Feet on top, and in the bottom, second. So your final unit is feet over second. Plug in these numbers. 75 times 5280 divided by 60 times 60. One suggestion I have for you when you're plugging this into calculator, plug all the numerators first. Put this in parentheses. Then in your calculator put divide, and then put all of this in parentheses as well. So always put your numerators in parentheses and then your denominators also in parentheses. Use a lot of parentheses when you're doing multi-step addition, subtraction, multiplication, division using a calculator, because without parentheses your calculator will not be able to give you the right answer. The final answer is 110 feet over seconds. This was given to you 2 significant figures. So my final answer should be 2 significant figures. This 0 is not significant, right on the right without any decimal. Okay, then the last part for this particular part of the chapter is volume. We have already discussed most of this. Volume by calculation, length times width times height or thickness. 1 liter is these many cubic centimeters, or 1 cubic centimeter is 1 milliliter, whichever one you want to remember. Basically, if you need to convert between liters and cubic meters or cubic centimeters, you can use this conversion factor. There are a couple ways, other ways that we can measure the volume. So for example, in the previous one we saw this is a solid. Length times width times thickness or height will give you the volume. But what if my object is like irregularly shaped? It does not have, it's not a cube, it's not a cuboid. How would we measure that? If I want to measure the volume of this irregularly shaped wire, for example, let's say if I take a wire or a rope and I just wind it around itself, and I want to know what's the volume of this wound up wire or cord. That you can figure out by doing volume by displacement. This is an experimental approach, volume by displacement, which is what you take a graduated cylinder which has markings on it. You partially fill it with water. Partially means anything. For example, in this case, I just happen to fill it up to the 50 ml mark. Now I'll take this irregularly shaped object and I will drop it into this water. What will happen? As the sample goes in, the water level would increase. Why? Because you have added extra volume that comes from this sample. Now, whatever is the extra volume that happened, that change in the volume is because of your object. So that means that is the volume of the irregularly shaped object. So in this case, it was 50. Now, finally, it is 60.5, which means volume of my object is the change in volume, which would be 60.5 minus 50.5, which is 10.0 ml. Oops, sorry, not 50.5. This was 50 ml, 50.0. So that would be 10.5 ml, and you're done. Another time you need this volume by displacement is when we are measuring volume of a gas. For example, if I do a chemical reaction in this container, in this test tube, and it produces gas, how can I measure the volume of a gas? There's an easy way. You connect this with a cylinder or a round bottom flask, in this case this flask, which is filled up with water, lot of water in here, and I will connect this flask with a beaker as well. Now as you heat this test tube, a reaction occurs, gas is produced. The gas does not have anywhere else to escape, so it exits through the tube, and through this tube it enters into the flask. Once it enters flask, it requires volume again, so it goes and finds volume. As long as the flask is filled up with water, there will be no space. What will happen? The gas will put pressure on this water, and the water from this flask will enter into the tube, and it will get dropped out into the beaker. So let's say if during this process I collected, my beaker initially was empty, now I've collected 50.0 ml of gas. That means the volume of gas that was created during this experiment is 50.0 ml. So this is called volume by displacement of water. You can use it to measure the volume of irregularly shaped objects or gases. Okay, why do we care about this? Let's try a question. Again, this is all dimensional analysis. You don't even have to know the formula for the measurement that we are making. An automobile engine displaces a volume of 498 cubic centimeters in each cylinder. What is the displacement of cylinder in cubic inches? So we simply need to convert cubic centimeters into cubic inches. What does cube mean? Remember, cube means this is centimeter times centimeter times centimeter. Inch means inch times inch times inch, which simply means I need to convert 1 centimeter into inch, then another centimeter into inch, then third time the centimeter into inch. Okay, so I have to repeat this process of conversion 3 times. Why? Because the conversion factor that I know is 1 inch 2.54 centimeter. This only has inch and centimeter, whereas what I need is cubic inch and cubic centimeters. So what do? We start with the starting number given to us, 498 cubic centimeters. We will multiply it with the conversion factor. Again, this is centimeter, so centimeter goes in the bottom. 2.54 and 1 inch. Now, because I need cubic centimeter, what can I do? I'll cube this whole number, which means I should also cube this whole number on top. So now this cubic centimeter and this cubic centimeter will cancel. But remember, when you cancel this cubic centimeter, that means this is 498 cubic centimeter times 1 inch cube, because 1 cube is same as 1, divided by 2.54 cube times centimeter cube. So I'm only cancelling centimeter cube, but remember that there's 2.54 cube. So a lot of times answer is 488 inch cube divided by 2.54 cube. So just plug this into your calculator, okay? But a lot of times where do students make mistake? They will write this cube, but they will cancel the centimeter cube, and they would just divide by 2.54, which is not correct. This cube is for the whole thing. It's also for 2.54. So just remember that. Or you just have to repeat this step 3 times, like shown here. 1 inch 2.54, 1 inch 2.54, 1 inch 2.54. Repeat it 3 times, you get the same answer. Let's try another example. Convert 2659 square centimeters into square meters. Square centimeters means this, square meter means this. What is the conversion factor that I know between the two units? The common thing is meter, which means that's my base unit. 1 centimeter is 10 raised to power minus 2 meters. You need to know this from the previous prefixes chart that we saw. Okay, but the important thing here is this is only 1 centimeter and 1 meter, right? They're not squared or cubed, but here everything's squared. So what do? I start with my starting number, square centimeters. I will multiply it with the factor centimeter. So centimeter goes in the bottom. 1 centimeter, 10 raised to power minus 2 meters. Now you have a choice. Either because this is squared, you square the whole thing and you calculate the number, or you just repeat this step 2 times because this is squared. So 1 centimeter, 10 raised to power minus 2 meters. So if I cancel this out, 1 centimeter will cancel one of these, 2 centimeter will cancel the whole thing. So now your final unit that's left is meter times meter, which is meter square. So 2659 times this, plug it into your calculator, and that would give you your answer. This is 4 sig figs. So your final answer should also have 4 sig figs, which would be 0.2659 for significant figures. And you're done.